In the name of God, the most gracious, the most merciful, peace be upon you and God's blessings, we will solve a practice problem for case 1 of Mohr's circle of inertia, where Ix is bigger than Iy and Ixy is positive. Use Mohr's circle to determine the maximum and minimum values of inertia for axes passing the left corner of the given triangle. We have a case of right angle triangle. The left corner will have an Ix value equal to BH cubed over 12, while the Iy value is equal to HB cubed divided by 12. The product of inertia Ixy is B squared by H squared divided by 24. The dimension of B equals 150 millimeters. The height H equals 200 millimeters. Ix value equals BH cubed over 12 equals 150 multiplied by 200 raised to the power of 3 divided by 12 equals 100 by 10 to the 6 millimeter to the 4. Iy value equals H by B raised to the power of 3 divided by 12 equals 200 by 150 raised to the power of 3 divided by 12 equals 56.25 by 10 to the 6 mm4. Ixy value equals B squared by H squared divided by 24 equals 150 squared by 200 raised to the power of 2 divided by 24 equals 37.5 by 10 to the 6 mm to the 4. As we can see, Ix value, which is 100 by 10 to the 6 mm4, is bigger than 56.25 by 10 to the 6 mm4. The Ixy value has a positive value of 37.5 by 10 to the 6 mm4. To draw Mohr's circle of inertia, we need to find the radius of the circle of inertia. The radius is equal to the square root of Ix minus Iy divided by 2 all squared plus Ixy raised to the power of 2. We apply in the equation. We find that the square root of 100 minus 56.25 divided by 2 all squared plus 37.5 squared equals to 43.4138 by 10 to the 6 mm to the 4. These are the step-by-step procedures to construct Mohr's circle of inertia. Number 1, draw a horizontal axis representing Ix, Iy, Imax, I minimum. Number 2, draw a vertical axis representing Ixy in the upward position where Ixy is positive. Number 3, locate the point which has a coordinate of Ix, Ixy. Point A is drawn at the right side and with Ixy upward. Consider one unit is 10 to the 6 mm4. Point A coordinate is 100 units, 37.5 units. Number 4, locate point B where a coordinate of Iy minus Ixy. The point B is drawn at the right side and with Ixy downward. Point B coordinate is 56.25 units, minus 37.5 units. Number 5, join the 2 points A and B and cut the x-axis in point O. Number 6, draw the circle with the radius equals to OA equals to OB. The radius value is 43.4138 units, approximated to 43.414 units. Point O coordinate is obtained from the relation Ix plus Iy over 2 equals 100 plus 65.25 all divided by 2 equals 156.25 divided by 2 equals 78.125 units. Coordinate of O is 78.125, 0 as units. We can get the maximum value Imax equals Ix plus Iy divided by 2 plus the radius r equals 78.125 plus 43.414 equals 121.539 units. The point of maximum value of inertia in Mohr's circle is represented by point E. I minimum equals Ix plus Iy over 2 minus the radius r equals 78.125 minus 43.414 equals 34.711 units. For values of inertia, multiply units by 10 to the 6 mm to the 4. The point of minimum value of inertia in Mohr's circle is represented by point C. After we draw Mohr's circle, we can find the value of angle 2 theta B1, but first we draw the mirror point A dash with a coordinate of Ix, minus Ixy, or 100, minus 37.5 units. The U direction is the line OA dash. The angle 2 theta B1 can be estimated by finding the tan value, which is equal to minus 37.5 divided by 21.875 equals minus 1.714. Using calculator, 2 theta B1 equals minus 59.743 degrees, and it is in the fourth quarter. In the next slide, extend the line A-O to locate point B'. It is also a mirror point of point B. Its coordinate is 56.25, plus 37.5. We can find that line CA' represents the direction of the U-axis in the normal view. The angle theta B1 equals minus 59.743 divided by 2 equals 29.8715 degrees. The line CB' represents the direction of the B-axis in the normal view. The angle theta B2 equals 90 minus 29.875 equals 60.128 degrees. In the next slide, we gather all the information. We have Imax or IU equals 121.539 by 10 to the 6 mm4. We have I minimum or I sub V equals 34.711 by 10 to the 6 mm4. The value of theta B1 equals minus 29.8715, which is the angle enclosed between the axis U and XX, as shown in the small sketch on the left side of the slide. Theta B2 equals 60.128 degrees in the anti-clockwise direction. The product of inertia for the major and minor axes is I sub UV equals 0. The list of all of the data Ix, Iy, and Ixy is shown in the slide. It is better to check that I polar, which equals Ix plus Iy, has the same value as Iu plus Iv. I polar equals 100 plus 56.25 equals 156.25 by 10 to the 6 mm4. Check Iu plus Iv equals 121.539 plus 34.711 equals 156.25 by 10 to the 6 mm to the 4. In the next slide, we will be estimating the values of Ix dash by using the general expression of Ix dash as Ix plus Iy over 2 plus Ix minus Iy over 2 multiplied by cosine 2 theta minus Ixy sine 2 theta. We have all the values of Ix, Iy, and Ixy listed. For the Imax, we consider 2 theta b equals minus 59.743, which has a cosine value of plus 0.5039. Its sine value equals sine minus 59.5743 equals minus 0.86377. We apply in the equation of Ix dash, then I sub u equals 10 to the 6, open one bracket, 156.25 divided by 2 plus 100 minus 56.25 divided by 2 multiplied by 0.539 minus 37.5 multiplied by minus 0.86377 equals 121.54 10 to the 6 mm4. In the next slide, we will be estimating the value of Iy dash by using the general expression of Iy dash as Ix plus Iy over 2 minus Ix minus Iy divided by 2 multiplied by cosine to theta plus Ixy sine to theta. We have all the values of Ix, Iy and Ixy listed. For the I minimum, we consider 2 theta b 1 equals minus 59.743, which has a cosine value of plus 0.5039. Its sine value equals sine minus 59.743 equals 0.86377. We apply in the equation of Iy dash, Iv equals 10 to the 6 multiplied by 156.25 over 2 minus 100 minus 56.25 divided by 2 multiplied by 0.5039 plus 35.5 multiplied by minus 0.86377 equals 34.71 by 10 to the 6 mm to the 4. In the last slide, consider the u-axis as your datum and modify the Ixy axis by making it parallel to line OA, and at the left of the OA by a distance of Ix plus Iy divided by 2, which equals 100 plus 56.25 divided by 2 equals 78.125. The coordinate of the center point is 78.125, 0. Now we have the x-axis as a horizontal axis. Check for theta b. We find point E with a coordinate of Ix, Ixy, which is 100, 37.5. Check for theta equals to pi over 2, then to theta equals to 180. Anti-clockwise, we find point B with a coordinate of Iy, minus Ixy, or 56.25, minus 37.5. The distance Iy is measured from the Ixy new datum, while the Ixy distance is negative below the u direction. Thanks a lot and see you. Goodbye.